this video is for Math 60 for the percentage word problems assignment. And I've got some formulas or equations up on the board for how to work with percentages. We've got the formula is over of equals percent over 100. And sometimes it's helpful if the words is and of don't appear in the problem to think of is as the part and of as the whole. There's also this formula, use the percent as a decimal, times of equals is. And whichever one makes more sense for you, that's the one that you should use. Okay, I'll probably use both of them in making these calculations. Let's take a look at problem 2. This one is, I think, one of the more straightforward problems on the assignment. And it says we've got a saltwater solution that weighs 8 ounces and contains 18% salt. And so the question is, how many ounces of salt are in the solution? So, if you think of the solution itself as the whole, okay, the 18 is clearly the percentage, and we're looking for the part, which is the salt, the amount of salt in the solution. Let's see here. Okay, so we're looking to find what is, so if this question were phrased differently, it would say, what is 18% of 8 ounces? That's the question that we're looking to answer. So, in the, using this scenario right here, we're looking for the is part of the whole is 8 ounces, and we know that the percentage is 18%. And so we would calculate 8 times 18 and divide it by 100, and that comes out to be 1.44. Using this method here, the percentage as a decimal is 0.18. Of is the whole, so we multiply it by 8, and that'll likewise give us 1.44 ounces of salt. Okay, so like I said, that's one of the more straightforward problems on this assignment. It's kind of, I think, a warm-up to get us ready for these other problems where we have to make a calculation like this and then move forward from there. Okay, so let's take a look at problem 4. Problem 4 says how much pure alcohol is in 150 milliliters of a 30% alcohol solution. That question very similar to question 2, but then the problem goes on from there. So first let's answer that first question, okay? And then we'll take a look at the rest of problem 4. So how much pure alcohol is in 150 milliliters of a 30% alcohol solution? So, like I said, this one gets set up very much like problem 2. We've got 30%. The whole is the solution itself. That's 150 milliliters. We're looking for the part that is the alcohol in it. And so to answer this question, we would do 150 times 30 and divide by 100. And that comes out to be 45 milliliters. The other thing we can do here is take the percentage as a decimal, 0.30, multiply that times the whole, or the of, which is 150, and that'll give us the same answer, 45 milliliters. Okay, now, what's different about this problem is that it doesn't end there. Problem 4 goes on to say, what if 50 milliliters of water were added to the original solution? So we start out with 150 milliliters, and we add 50 milliliters of water to it. So now the solution is 200 milliliters. We've still got the 45 milliliters of pure alcohol in there. Okay, because what we added was just water. Okay, so this is the new scenario. And then it says, what would be the percent concentration in the new solution? Okay, well now we're looking for the percentage. Now we know the part is still 45. The whole has changed from 150 to 200. And we're looking for the percentage. Okay, so there's the setup for that problem. So we would say, what, 45 times 100 and then divided by 200. And so that tells us that solution would decrease to a 22.5% concentration. It started out at a 30% concentration. We diluted it with 50 milliliters of water, and now the concentration is down to 22.5%. Using this method right here, you would say the percent as a decimal times of, which is the 200, equals is, which is the 45, and then we divide on both sides by 200, and we get x is 0.225. And then we turn that into a percentage by multiplying it by 100, essentially. Okay, so there's problem 4. And so you can see how these problems start out with just this scenario right here, but then we're making changes to it, or we're mixing things together. And these problems are very realistic. They happen a lot in a lot of different industries, you know. I think the brewers do this, bread makers do this, chemists do this, people in healthcare have to do this. It's an interesting application of percentages. All right, let's take a look at problem 6. Problem 6 says 2 cubic meters of soil containing 35% sand. So we've got 2 cubic meters of soil, and this is a concentration of 35% sand. Okay? And then we're going to mix it with 6 cubic meters of soil that's only 15% sand. What percent sand is the 8 cubic meter combined soil? Now, right here, this is easy. We just add the 2 and the 6 to get 8. Over here, how these percentages mix with each other depends on how much of each of them we have, okay? And how much sand is in each one. That's really the question here, okay? And so we want to go back to what we did in problem 2 and problem 4, find out how much sand is in this one, how much sand is in this one, okay? For the first scenario, we're looking for the part, which is the sand. The whole is 2 cubic meters, and the percentage is 35%. In the second scenario, we're looking for a part. I'll use y here, over 6 equals 15 over 100. The whole is the 6 cubic meters. The percentage is 15. Okay, so if we multiply 6 times 15 and divide by 100, we get 0.9 cubic meters of sand in this one. And in this one, we do 2 times 35 divided by 100, and this one would be 0.7 cubic meters of sand. And so the total amount of sand then is going to be 1.6 cubic meters out of the 8 cubic meters that we now have, adding the 2 and the 6 together. So now the problem becomes, we've got 8 cubic meters of soil. We know that 1.6 cubic meters of it is sand. What's the percentage? Okay? So the part is the sand. That's 1.6. Let me get a different color marker here. So the part is the sand. That's 1.6 cubic meters. The whole is the 8 cubic meters, because that's all we've got. And we're looking to calculate a percentage. Okay? So, what we want to do here is 1.6 times 100, and then divide that by 8, and that tells us 20%. X equals 20%. Okay? Notice that when you mix these two percentages, your resulting percentage is always between them. Okay? How close it ends up to each one depends on, like we had more of the low sand concentration, and so the end result is closer to that percentage. This one had 35% sand, but we didn't have very much of it. okay? And so the percentage didn't end up that close to 35. All right, so there's problem 6. Let's see here. Now, problem 6 goes on. What does it say? It says, what if another 3 cubic meters of sand was added to the existing mixture of combined soil? What percent sand would the resulting 11 cubic meters of soil be? Well, so we've got this scenario right here. We've got 8 cubic meters of soil. 1.6 cubic meters of it is sand. Now we're going to add to that another 3 cubic meters of sand. So yeah, the denominator is definitely going to be 11. The numerator is going to be 4.6 because we're adding sand. If we were adding something that didn't have any sand in it, we would only add it to the bottom, kind of like we did, I think it was problem 4, where we were looking at that alcohol solution and we just added water. So that only affected the denominator. Here, we're adding sand, and so that affects the total and the amount of sand in there. Okay, so now we want to calculate this. We want to do 4.6 times 100 and then divide by 11. And I think the problem says to round to the nearest tenth of a percent, so this would be 41.8%. Okay. Let's see here. Yeah, so now the situation is different because we're adding all this sand back into the mixture, and that pushes the percentage past what we started with. Okay, that's an interesting problem. All right, let's take a look at problem 8. Okay, problem 8, we've got 5 fluid ounces of a 2% alcohol solution. So, fluid ounces with a 2% concentration, pure alcohol. And we're going to mix that together with 11 fluid ounces with a concentration of 66% alcohol. Now this is very much like that problem that we just saw with the soil and the sand. Okay? These two things are going to get mixed together. We need to find out how much pure alcohol is in them. This part's easy. We're going to have 16 ounces, 16 fluid ounces to end with. But the percentage, we're going to have to find out how much alcohol is in this one, how much alcohol is in this one, add those together, find out what percent of 16 is that. Okay? So, let's go ahead and do that. The part is what we're looking for. The whole is the 5 fluid ounces. The percentage is 2%. In the second scenario, the part is what we're looking for. 11 is the whole. The percentage is 66%. This is not going to decrease from 66% very much. Okay? We're not at, well, let's take a look at it. I'm making predictions. I'm not sure exactly how it's going to turn out, but that's my prediction, is that the 66 won't decrease very much, but let's take a look at it. So let's see here. So we're finding 2% of 5 fluid ounces, and so we can do 5 times 2 and divide by 100, and that'll give us 0.1 fluid ounces. Here, 11 times 66 divided by 100, and that gives us 7.26 fluid ounces. So when we add these together, we get a total of 7.36 fluid ounces pure alcohol in a mixture that is 16 fluid ounces. And we're looking for what percent concentration is that. So we would do 7.36 times 100 and then divide that by 16, and this comes out to be 46%. So I was wrong. That actually did decrease quite a bit. Okay. Well, I'm glad I didn't go on and on about how it wasn't going to decrease very much, because I kind of caught myself in the middle there, and I took a closer look at it. But anyway, it did actually decrease quite a bit. All right, let's see. Did we answer all the questions for problem 8? Find the percent concentration alcohol in the new mixture, 46%. Okay. All right, let's take a look at problem 10. All right, problem 10, we've got 10 pounds of candy that cost $5 per pound. So 10 pounds of candy that costs $5 per pound. All right, and we're going to mix that together with 40 pounds of candy that sells for $8 per pound. Now notice that we're not using percentages in this problem, okay? So we're not necessarily going to be doing this right here. Let's see here. How much per pound should the new mixture be sold for? So here's what we're interested in, is how many pounds are we going to end up with, and how much is that candy worth? Okay, so you've got 10 pounds of candy that sells for $5 per pound, so it's worth $50. You've got $50 worth of candy here. In this one, you've got 40 pounds of candy that's worth $8 per pound, and so this is worth $320 total. I'm just multiplying these numbers together. 5 times 10 is 50, 8 times 40 is going to give you 320. So all the candy together could be sold individually for $370. And it's 50 pounds. So to find out how much per pound to sell this mixture for, if we don't want to, cheapen the prices that we've already got, okay, we want to do 370 divided by 50. Notice how this per pound, remember back from chapter 1 that per means divided by. So per pound means we want to divide this by the number of pounds. And so we'll do 370 divided by 50, $7.40 per pound. And so that's the way to approach a problem like that. Problem 9 is very much like that. Let's see, I guess the rest of these are mostly about percentages, except for problems 9 and 10. All right, so you've got an answer key for these problems. If you have any questions about how to do them, please let me know. Thanks a lot.